Hey guys, it's Miss Johnson and I'm here to bring you our notes for our first lesson of Chapter 2. Today we are talking about percentiles and cumulative relative frequency and then also finding a z-score, normalizing our data using z-scores. So Chapter 2 gets into normal distribution, and normal distribution is what we will primarily be working in for a vast majority of this entire course. We use normal distribution every day from here on out, pretty much. So you're going to hear a lot about normal distribution. You're going to hear a lot about z-scores, which is what we use to normalize our data. And we are going to work with those all the time throughout the rest of this course. If you didn't already have your calculator out, we are going to do some basic calculations today. So you might want to have your calculator out while you're taking notes today. And yeah, let's go through some examples. So measuring percentiles in a data set. Before we get into the normal distribution piece, we're going to talk about measuring percentiles. One way to describe the location of a value in a distribution is to tell what percent of the observations are underneath it, are less than it. So an individual's percentile is the percent of values in a distribution that are less than that data value. That's an important thing to note. We're looking at the ones that are underneath your individual data. Okay, so let's take a look at an example. It says Jenny earned a score of 86 on her test. How did she perform relative to the rest of the class? Here's our stem and leaf plot. Okay, you have a stem and leaf plot here. Your stems are down the left-hand side and your leaves are on the right-hand side. They didn't put a key, but the fact that they told you the test, you can determine what the scores are. So here's Jenny. Jenny is this one, 86. That's the data set that she's looking at. So what you want to figure out is what percentile is she? It's a lot more common for us to talk in terms of percents. Percents make sense to the average human. When you are talking in terms of money or any sort of data at all, when you speak in terms of percents, people understand. They understand the percent is out of 100. So percentiles is a really easy and applicable way for people to think about data sets. So we want to figure out Jenny's percentile. When we are trying to determine Jenny's percentile, what we need to determine is how many data values are underneath her. So we locate her value is right there, and we need to count how many data values are below. So you can see them highlighted in purple here. You see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21 of the 25 observations are underneath Jenny's score. So when you think about that as a percentile, that's all you would do is take 21 divided by 25, which gives you a decimal or a proportion of 0.84. And we all know that in percentiles or in percents, we move our data over two places, we move our decimal point over two places and we get 84%. So that's why we say she is the 84th percentile in the distribution of her class's scores. All right, so that's how we find a percentile. It's pretty basic. We look at the data values that are underneath it and take that, divide it by the total, and you get the percent that you are in whatever group you're looking at. Now let's talk about cumulative relative frequency. Cumulative relative frequency. What cumulative relative frequency does is it starts with the lowest interval, and then you are going to calculate the frequency of that interval and add it to each row as you continue down the table. So it's like you're starting with the 0%, you're starting at the very bottom, and you're adding the frequency, and by the end, you should get all the way up to 100% of the data because you're adding the relative frequency for every single row to the previous total. So here's your kind of technical definition. It says a cumulative relative frequency plots a point corresponding to the cumulative relative frequency in each interval at the smallest value of the next interval. So you start with a point at the height of 0%. It's the smallest value of the first interval. And then consecutive points are then connected with a line segment to form a graph. So you can turn cumulative relative frequency into a graph. We're going to calculate it in this table, and then we'll talk about what it looks like in a graph. Okay, so if you didn't have your calculator out before, now you are going to want to have your calculator for this example. So what we're given here is we're given an age and we're given a frequency, and it says age of the first 44 presidents that were inaugurated. Okay, so the lowest age is 44, or is in the 40 to 44 interval. The highest age is in the 65 to 69 interval. Okay, and then you see the frequency of each of those intervals in the next column over. What I want to do next is I want to calculate the relative frequencies of just those answers there. In order to get, or of just those frequencies, in order to get the relative frequency, the first thing that I have to do is I have to find a total. You know you're looking at 44, but if you add up all those frequencies, you should also get to 44, and we can just check and make sure that that's what the table is actually reflecting. So I'm adding them all into my calculator, and I get n is equal to 44. So if I want to find the relative frequency of the first row, I'm going to take 2 divided by 44, and that's what percent of data I have in that row right there. So when I take 2 divided by 44, that's 4.5% of the data. Okay, so I got 0.04545 repeating on, which is 4.5%. So that's my relative frequency for the ages of 40 to 44. 4.5% of the first 44 presidents were between the ages of 40 to 44 when they were inaugurated. Okay, let's do the next one. 7 divided by 44. 7 divided by 44 gives me 15.9%. So 15.9% of the first 44 presidents were between the ages of 45 and 49 at inauguration. Let's do the next one. 13 divided by 44. And I hope you're typing these into your calculator along with me so that you can make sure that you know how to type them in on your own and you see where I'm getting my numbers and what data you should have. So 29.5% of the presidents were between 50 and 54. 12 divided by 44 is 27.3. 27.3%. 7 divided by 44 gives me 15.9, and we already did that one, but that's okay, I typed it again. And then 3 divided by 44 gives me 6.8. Okay, so there are the relative frequencies of just that frequency column, okay? The next column over, I'm gonna do cumulative frequency. So cumulative, if you think about the word cumulative suggests some sort of combination. We're adding up our frequencies as we move down each row. So if I look at the cumulative frequency in the first row, I'm really just looking at 2 because I've only got one row combined. In the next row down, I'm going to take the 2 plus the 7 that exist there, and my cumulative frequency is 9. In the next row down, I'm going to keep adding. So I had 9 from the first 2 columns, and then I'm going to add the 13, and that gives me 22. The next row down, I'd have 22 plus 12, which gives me 34. So I'm taking this, just so you can see what I'm doing. I'm taking the 22 that I had, and I'm adding the next frequency. Now I take the 34, and I add the 7. 34 plus 7 gives me 41. And then I take the 41 and add the 3, and that gets me to 44, which is what I should get. By the time I get to the end of that frequency table, I should be at my total n. So you can see that my cumulative frequency worked out, which is great. Now I'm going to go ahead and calculate the cumulative relative frequencies. So it's like I'm putting those two concepts together. So cumulative relative frequency. So we basically are going to put those two things together. If I take 2 and divide it by 44, I'm going to get the same answer that I got over here because I'm still looking at the same value. So now it's like I'm taking this column right here and dividing it by 44. So 2 divided by 44 is still 4.5%. Now I'm going to look at 9 divided by 44. So that's 20.5%. Then I'm going to look at 22 divided by 44, which is exactly 50%. Then I'm going to look at 34 divided by 44, and I get 77.3%. Then I'm going to look at 41 divided by 44, which is 93%, actually like 93.2. And obviously, we all know this, but 44 divided by 4 is 100%. Okay, So that's our cumulative relative frequency as we go down the table. What this does for us is this tells us 77.3% of the presidents, let's say I'm looking at this one right here, 77.3% of presidents were under the ages of 59 when they were inaugurated. That's what that's telling me. Or I could say 50% of the presidents were under the age of 54 when they were inaugurated. Okay, that's what cumulative relative frequency does for me. The other way that you could have calculated this column that's in red right here, you could have just added these relative frequencies down this column. If I take 4.5 and I add 15.9, I end up with 20.4, which is about the same as that 20.5. Okay, if I took the 20.4 and added the 29.5, which is the next row, I get 49.9. Okay, if I take the 49.9 and add the 27.3, I get 77.2. You can see that I'm a tenth off, and we'll talk a little bit about why. 77.2 plus the 15.9 gives me the 93.1, still about a tenth off, and then 93.1 plus the 6.8 gives me 99.9. So you can see that you get almost the same answers if you just simply add and then add and then add with your relative frequencies. The reason I don't necessarily love using that method is because of the element of rounding. All of these relative frequencies had to be rounded. So you can see that in the blue numbers, I got down to 99.9%. We all know that 44 out of 44 is 100%. Somewhere in the rounding, I lost a tenth of my data. Now, that's really common in this class. We've talked a lot about how statistics is messy, it's not perfect, data doesn't always turn out really pretty, and this is just another example of that. But you get just a tad more accuracy if you do it this way versus if you do add the relative frequencies. So some people don't even take the time to find out that column. They will just simply find the cumulative relative frequency, and then they'll take this divided by the total of 44 to get that. And they'll do that all the way down instead, because you just get a little bit more accuracy if you only have to round one time. All right, so you can see our table filled in now. We filled in the table on the previous slide, but this is just a picture of how we calculated those values in case you needed a little bit more visual representation of that. Here it is. Then what is really common with cumulative relative frequency is to then take this table and turn it into a graph. So age at inauguration is my x-axis, cumulative relative frequency in percent is my y-axis, and then you can see they scaled it from 40 up to 70, and they have your percents from 0 up to 100. What always happens, this is always true with cumulative relative frequency, you start at 0 and you end at 100. If you're doing cumulative relative frequency, you should be starting at the bottom of your data set and working all the way up to the end of your data set, which will include 100% of the data. And then you're just marking your points at those intervals along the way. So you can see that at the age of 44, actually 45, that's where they marked the 20, or that's where they marked the 4.5, because at the end of 4 and 4, at the end of the first interval, the 44, was where the 4.5% was. Then if you go all the way up to 49, you're at that 20.5. Then if you go up to 54, you're at 50%. Then if you go up to 59, you're at the 77.3. If you go up to 64, you're at 93.2, and going up to 69 is 100. Okay, so they're all the way up at 100% there. All right, so those two first things that we talked about, finding a percentile is a really, it's a pretty simple concept. You just look at the data points that are below the one you want, divide by the total, that's your percentile, okay? Then with cumulative relative frequency, we use those percentiles a lot to look at our data set, where it starts and where it ends, and how it increases throughout the set as we go along. One other big thing that we're gonna do in this chapter is talk about normal distribution. And normal distribution involves something called a standardized score, or in other words, a z-score. So you're gonna see this word, z-score, find the z-score, find the z, find the z. You're going to hear us talk about finding the z quite frequently in this class. And what a z-score is it tells us how many standard deviations from the mean an observation falls. We spent a lot of time talking about standard deviation in chapter 1. The standard deviation was the typical amount of distance from the mean of your data. Okay, now your data can be several standard deviations away from the mean. It may be one standard deviation away from the mean. It may be a standard deviation below. It could fall above the mean, it could fall below the mean. And what a z-score does is it tells you how far away from the mean a certain data value is based on the standard deviation. Okay, this is a really simple calculation right here. You always want to take the data minus the mean and then divide it by the standard deviation. This numerator right here, this is your distance, okay? Your distance from the mean is that numerator. This is your typical distance. That's what standard deviation is. So you can take the distance from the mean and divide it by the typical distance to get the number of standard deviations away. That's what you're finding there. Okay, so you're going to use this calculation a lot, and of course, like everything else in this class, there's a way that we can do this on our calculators as well. So we will get to that point, but for now, we're going to calculate this by hand, because if you look at it, it's a subtraction in the numerator and then divide by one number in the denominator. Super simple to type into your calculator. So let's take a look at Jenny again. We're going to go back to Jenny and her test score. Jenny earned a score of 86 on her test. The class mean is 80, and the standard deviation is 6.07. Find and interpret her standardized score. Okay, so I'm going to start by finding her score, which is a pretty easy thing to do like we just talked about. I need to take the data minus the mean and divide it by the standard deviation. So in this case, I'm looking at 86 minus 80 divided by 6.07. When I do that, you're going to get a decimal typically. These things don't often turn out really pretty and nice and clean, just like we've always talked about. If I take 6 divided by 6.07, I get 0.99. Okay, typically our standard deviations go out to the hundredths place. So I would round that 88 up to the 9, okay? If you typed that into your calculator, you can see what I'm looking at. But anyways, we're gonna go out to the hundredths place and we're gonna round there. Okay, that's the easy part. This is the part that causes some struggle sometimes. So the interpretation of this z-score is something that takes a little bit more thought and effort. This is where you actually say, what does that z-score mean? What does that mean to our data set? Okay, first of all, I want you to take note of the fact that the z-score is positive. So that means that Jenny's score is above the mean, which we can obviously tell because her score is 86 and the mean was 80. So we know that her score is above the mean. That's an important thing, okay? The other thing is we want to talk about what those two things are, and we have to put it in context of the question. So the way I would write out my interpretation is Jenny's test score is 0.99 standard deviations here's where the direction comes into play, above, because you're either going to say above or below, above the mean of 80. Okay, so we need to put it in context. We need to talk about what the standard deviation is. We also need to make note of the mean, okay? Those are all things, and you have to put the direction, okay? Direction is important, standard deviation is important, context is important, naming the mean is important. Those are all the things that you have to have in your interpretation, okay? So that tells you that she's just about one standard deviation above the mean, and you can kind of get a picture of what that is. When we get into normal distribution, we start drawing those normal curves, it will make a lot more sense to you as to what we're looking at. One thing that they do make note of, and this is one thing that I also just said on the previous slide, is do not interpret the z-score as distance away. We always want to indicate whether the value is greater than or less than. That's that above or below the mean. Okay, so that's just an AP exam tip, if you will, because they're always going to want to know the direction. All right, that takes us to the end of our notes for today. So thanks for listening. This is just the first part of section 2.1 in your book. Go ahead and work on your practice assignment, and if you have questions, let me know. Thanks for tuning in, and I'll see you next time.